Hello chemistry students. Today we're going to look a little deeper into the periodic table and learn some tools for predicting chemical reactions. We already know that the periodic table is divided up into families, and we're going to look primarily at the alkali metals, alkali earth metals, and then this group, the transition metals, we're going to skip for now and go over to groups 13, 14, 15, 16, 17, and 18. These are called the main group elements, and these in the middle are transition elements. So we're going to start looking at phosphorus. We look it up on our reference table. It has 15 protons and 15 electrons when it is neutral. And so a neutral atom has 15 of each. Now, in order to fulfill the octet rule, though, phosphorus will tend to gain 3 electrons. It has 5 valence electrons to start with, and it needs 3 more to get to 8. Now what happens then is we still have 15 positive charges, and we have 18 negative charges, and that means our net charge will be minus 3. So we would write this like this: phosphorus minus 3. Another way to look at it is to use the Lewis dot diagram, which just shows the valence electrons. And we can look and see that, well, there's 5 valence electrons, and we would need 3 more in order to fulfill the octet to have 8 valence electrons. And so we would write that one also as a P-3 ion. This is the charge that phosphorus would tend to form in order to fulfill the octet rule. Now let's look at sodium. That is a different story though. Sodium has 3 energy levels and 1 electron out there on its own, far away. So the electron being held there by the attraction between the electron and the proton, but it's also being repelled by these, what we call shielding electrons. So the sodium atom doesn't have quite as good a hold on that electron. So what tends to happen is somebody like phosphorus, which is desperately trying to attract electrons, comes near it and it steals away that 1 electron. And now sodium has 2 energy levels and its outermost energy level is filled. Now the result of this is we started out with 11 protons, but now we only have 10 electrons. So we will have 1 more positive charge than negative charge, and so we would write it like this: Na+. Looking at our Lewis dot diagram, you would say, oh wow, only 1 valence electron. And if we take that one away, the outermost energy level will be filled, and we would have our sodium ion. And this number, this +1, would be the ion that sodium would tend to form in order to fulfill the octet rule. And there's some patterns. We already know that our groups, everyone in this group has the same number of valence electrons. And groups with 1, 2, or 3 valence electrons tend to lose. So they would have a +1, +2, or +3 charge. The noble gases that already are filled, they have 8, so they are neutral and they will not tend to get a charge. But our groups with 5, 6, and 7 valence electrons tend to gain electrons, and so they will have a negative charge. They will have more negative charges than positive charges. That's hard for people to wrap their head around, that will have a negative charge. Now oxygen, we want to look at oxygen because this is where the understanding of this all started. Oxygen's all around us and it really strips electrons. It steals them away. So oxygen started out with 6 valence electrons, and now it gains 2, it has a -2 charge. This was the first place that this was observed, and so it is called Oxidizing, when oxygen strips your electrons, or when anybody does, you're oxidized. And these numbers here, the charge that elements tend to form when they fulfill the octet rule, which is a lot to say, we can just say oxidation number, and people understand. Now, what you should do in order to make your life easier is get out your periodic table, and at the top, you want to write the oxidation number. The alkali metals tend to lose electrons, so they will have a +1. The alkaline earth metals tend to lose 2 electrons. They will have a +2 charge. We're going to scurry on over past our transition metals. We're going to go right here. The boron family +3. Now the carbon family, since they have 4 valence electrons, they can actually go both ways. These guys tend to gain, the ones at the metal ones tend to lose, and that is a little trickier than we're going to do in this class. So we're going to skip over that, and the nitrogen family tends to gain 3, the oxygen family tends to gain 2, and the halogens tend to gain 1. I would put that on top of your reference table. That will come real handy in a test and quizzes and in doing your work. Hope you have a wonderful day.